let's look at the different types of filters. And the filters is categorized based on the shape of the t function, the gain function. And the gain function tj omega, and we just saw that a moment ago in a for the low pass filter case. And more commonly, we don't really plot that gain in the derived plot that gain there. We transform that gain into the dB gain. And so this is the gain in dB. dB means decibel. Okay, so in this case, the this is related to the original gain by we take the log, base 10 log, and times 20. So that's how we find out. So in this case, if tj omega, if the gain is equal to, let's see, tj omega, let's see, if this is equal 1 over square root 2, and the 20 log of this to the dB, and then the tj omega dB is going to be equal to, let's see, at the cutoff frequency omega c. Okay, at omega sub c, and this is going to be equal 20 log 1 over square root 2. That's equal negative 20 log of 10 square root 2. Or if you think about it, 20 log 1 minus 20 log square root 2, 20 log of 1 is equal to 0. So we got negative 20 log. So this is roughly equal negative 3 dB. Okay, negative 3 dB. So if the Tmax, right, if the Tmax is at low frequency, Tmax divided by the square root 2, which is when you transform into the dB, that's going to be the Tmax dB minus 3 dB. Okay, so that's the where we are. So the first one we call the low pass filter. So this is low pass. The low pass filter, we have this basic redraw of the low pass filter we had before. The only difference here, rather than drawing the tj omega, the gain function itself, we are drawing the gain function, the dB version of that, right? So basically we take a 20 log of this gain function. So in this case, the Tmax dB, Tmax dB is, so let me write here, Tmax dB is still, the notation is still the same. That's equal 20 log of 10 Tmax. Okay. So that's the that's for the low pass, and we can see the pass band at the low frequency, the lower than the corner frequency or the cutoff frequency. Now we actually see the corner kind of more clearly, right? So now we have this round corner now is really has much narrower transition frequency range, right? So that's the beauty of drawing this in terms of tj omega, in terms of the dB. And in this case, this may be this will typically be a straight line as the frequency go higher for the low pass filter, and this may be dropped at negative 20 dB per 10 times the frequency we call the per decade, and we're gonna see that in the next lecture as we do the Bode plots. Okay, but this is shape of the low pass filter, and for high pass filter, the kind of opposite. So the pass band at a higher frequency and the stop band at a lower frequency. And the same thing here is the omega c. We separate the pass band and stop band by reading where is a frequency that has the Tmax minus 3 dB. So that's minus 3 dB is really critical to identify the corner frequency And then another type, so this is called a high pass filter. I didn't write this, I should. So this is a high pass. Another type is, this is seeming more complicated, right? So now we have two corner frequencies. Both are the cutoff frequencies. I'm writing as one word, not hyphenated. Cutoff frequencies. These two are. So in this case, the passband is between these two frequencies. And the stop band, it has two frequency ranges. One is below the lower cutoff frequency, and the other one is higher than the cutoff frequency, higher than the high cutoff frequency, right? So that's for the pass band, because there's only a narrow range you can pass through the signal without really attenuate that much. Otherwise, at low frequency, the signal will be kind of shrunk or attenuated. So another one is called the band stop filter. So this is called band pass filter. And the last one is called the band stop filter. Just writing in one word, band stop filter. And in this case, the stop band is between two cutoff frequencies, right? So that we still have to, and then now the pass band at lower frequency, lower than the omega sub C1, and above the higher cutoff frequency, omega sub C2. So these are the four different types of filters. And we're going to look at body plot, and then we're going to also look at the first order the filters and second order filter. Those are the three lectures for the next three lectures for this chapter. Okay, so this will conclude this part for the discussion. I'm gonna have another video clip for the example we had, right? So I see you in that video clip.